Welcome to a lesson with Dr. Powell. Let's look at an example of L'Hopital's rule, where we have a fraction where the top is headed toward infinity and the bottom is headed toward infinity. So let's take a look at a limit as x approaches 1 from the right side of the natural log of x minus 1 all over 1 over x minus 1. Okay, so notice that when we plug 1 in, this isn't defined. In fact, as x goes to 1, this part right here is actually heading toward positive infinity. This part right here is headed toward negative infinity. So now if we're using this rule, we need to kind of at least notate this to point this out, that we understand what things are headed to and why, then we can use it. So let's go for it. In using this rule, we take the derivative of the top on the top of the fraction, and then we take the derivative of the bottom and put it on the bottom of the fraction. And these limits should be the same. So let's do that. So here the limit, so on the top, the derivative is 1 over x minus 1. And the derivative of the inside x minus 1 is just 1. So times 1, it's just that. The bottom, think of this as being x minus 1 raised to the negative 1. So think negative x minus 1 to the negative 2 times the derivative of the inside, which is just 1. So that would be what we have. But I'll write it like this: negative 1 over x minus 1 squared. Okay, so this is what we're doing now. Now notice that we don't have any natural logs or anything in here. So I'm just going to, let's just do some algebra to kind of rearrange this a little bit. Why don't we multiply top and bottom of this fraction by the exact same thing? X minus 1 quantity squared. X minus 1 quantity squared. Notice that down here, we get cancellation. We just have a negative 1 on the bottom, which will just contribute to a multiplication of a negative 1 overall. And we just look at the top. Notice we have that canceling with one of those powers. So we just end up having negative, and this goes, and basically it's just negative x minus 1 is what we're looking at for the limit. So then we plug in 1 and we end up getting 0. So that means our limit here is actually equal to 0. Thanks for watching.